All right, guys. Sorry about that. I have 5 o'clock, so we'll go ahead and get started so we can try to get you guys out of here as quickly as possible. I know it's the last session of the day, so bear with me. I'll try to make it as painless as I can. My name is Gabe Silva. I work on the data center network platform team. I'm a program manager, and my main responsibilities are NIC offloads. So today I'm going to talk to you guys about tuning your networks for specific workloads. Web servers, file servers. We'll talk a little bit about SQL servers at the end. I don't have any specific slides, so we'll talk a little bit about the roles, and if you guys have any specific questions for SQL Server at the end, feel free, or as I'm talking, feel free to ask those questions, because we've worked extensively with the SQL team to kind of fine-tune the offloads for them. I just wanted to call that out up front. But let's go ahead and get started. Again, my name is Gabe Silva, and this is Don Stanwyck. He'll be coming on at the end to help talk a little bit about NIC teaming. So first, before I jump into the offloads, I want to talk a little bit about the terminology that we use, and I'll also go through an architecture document that outlines kind of the figures that I use as far as a VM and what a NIC looks like, the VM bus and such. Then I'll jump into the features. On the plate today is RSS, VMQ, VRSS, SRIOV, followed by NIC teaming. So, getting started, everything starts with a processor. So when you look at your motherboard, you have a processor or a socket, and that processor is a package. It encompasses multiple NUMA nodes. So a NUMA node is a set of processors that have a local memory attached to it. Then within the NUMA nodes, you have multiple cores. So each NUMA node could have 8, 6 cores, which share that same local memory. And then you have the notion of a logical processor. A logical processor is different from a physical core in that when you have hyperthreading on, a core can have multiple logical processors. And for our purposes, that's actually important because a lot of these offloads don't recognize hyperthreaded cores. So as soon as you start using RSS or VMQ, and I'll jump into what those are exactly, you'll see that it'll only use every other processor. And that's because we don't recognize the hyperthreaded cores. Then you have the notion of a virtual processor. These are the processors running inside your VM. They're different from logical processors in that they don't actually affinitize themselves to a core. They're just time slices. And the hypervisor schedules them on any core it has available and tries to optimize that processing. And lastly, the notion of affinity. As I talk about a network adapter and the hardware queues on the adapter, they affinitize themselves to a processor. And what that means is that it prefers a processor. So that queue has an affinity to a processor means it's going to be interrupting that processor with the network traffic. And to go over the architecture I'll be using, the figure at the bottom, kind of funky rectangle, is our network adapter. Then we have our host, the parent partition. Inside the parent partition, we use LPs. Those are the logical processors. Different from the VPs that you see inside the virtual machine on the right. Then we have the notion of the Hyper-V extensible switch. It's a software abstract, so it's the switch that actually does the switching for the traffic for the VMs inside of that host. Then you have the VM bus, and the VM bus is the interconnect between our software switch, the vSwitch, and the VM. Inside the VM, you see the funny rectangle again, and that's going to be the VM NIC. Any questions before I go on? Go ahead.
Would the virtual processor be running threads over any of these logical processors over time?
Yes, that's correct. So the question was, the virtual processors inside the VM can be running across any of the logical processors inside the host. And that is correct. The hypervisor actually has a series of, I believe, 6 steps or 6 rules that it'll try to follow as it tries to schedule traffic onto a core. And the first is it tries to keep it local, and if it can't keep it local, it'll try another another processor inside the NUMA node, and then various smaller steps there, and then the last one I believe is to try a different NUMA node. So it does try to keep everything within the same NUMA node. Any other questions? Okay. So the first feature I have, yeah, go ahead.
Is concept sort of similar with other virtualization technologies, like for example VMware? Like, the concept of logical processor and virtual processor translated to.
I'm not that familiar with the VMware architecture, but I'm sure it's somewhat similar. I know they have virtual processors, or they're vProcs. I'm not exactly sure what they call it. I'm not sure what they do in the host, though, so, or how they actually schedule. Okay, so the first problem is you have a multi-core machine, and you want to use it as a web server. You have something like 16 cores on this machine, and you want to set it up to be able to handle traffic from multiple users. You see that all this traffic coming in is only being processed on one core when you have multiple cores available for use. So examples of this is you have a web server or a file server being accessed by everyone in your network. So what we did to alleviate that problem was implemented receive-side scaling. Receive-side scaling has been around for a while, and what it does is it distributes that network traffic among multiple cores in the host as it comes in. And RSS is for physical boxes only. So it'll distribute, receive, and send traffic on the core that is affinitized to. You don't have to do anything to enable RSS. In most server-grade machines, RSS is enabled by default. And it's very useful when you're doing large amounts of traffic processing. So to give you guys an idea of what's going on, you see we have the gray box at the bottom. That's your network adapter. Your network adapter has multiple queues on it. Here we have 4. As a packet comes in, we do RSS logic. And what the logic is we basically do a hash on the 4 tuple, which is the source and destination IP addresses and the source and destination ports. We take that hash, take the last bits of it, and place it into a static indirection table. That table maps to one of these queues, and that queue will then interrupt the correct processor. In this way, traffic from the same flow is always guaranteed to interrupt the same processor, thus keeping your cache local. So to configure RSS, we have multiple keywords. How many of you are familiar with RSS? And how many of you actually configure it to use something other than the default settings? Just 1? 2? So there's actually multiple ways to configure RSS. And what we found is a lot of people don't use it or don't know about it. There's a lot of processing that happens on proc 0. A lot of your UI processing and just system processing. So one of our recommendations is that you move your network processing off of core 0 and onto your upper cores. And you can accomplish this by using a couple of these keywords here. So the first one is get net adapter RSS. I'm actually going to jump into a demo here in a second and show you guys what that returns. It'll return whether it's enabled. It'll return the indirection table I was actually just talking about. The second one is set net adapter RSS, and this is the important one because this is where you can set your base processor, the max processor number you want it to use, and the max number of processors. And so this is important if you want to isolate your traffic on a certain set of queues and you want to finitize, say, an application processing on another set of queues. And that way, they never conflict. So let me jump into the demo. And then enable and disable net adapter RSS. That kind of does what it implies with a parameter. So all right, so I have a box here. This is actually a PowerShell commandlet in the host. And let me make this bigger for you guys. I'm sorry. So I did just a simple get net adapter RSS commandlet here. And you'll see that this is all the output for just one interface. So we see that it's a Broadcom NIC. It's enabled, it's set to true. Number of received queues is set to 4, so that's the number of queues it has available to you. The profile we're using is NUMA static. The base processor is set to 0, max processor is 15, and the max processors it'll use is 16. Now, the RSS processor array down here tells you the processors that are actually available for use for RSS. So here you'll see that we have, in group 0, we have pretty much all 15 processors available. And then you have this WAC 0 or WAC 32,767. Does anyone actually know what that is? Excuse me? Magic number. The number there is actually kind of magical. I'm not exactly sure what the scale is of the number, but what it does tell you is it tells you what NUMA node that network adapter is actually placed in. So if here you see that we have a 0 for processor 0, 1, 2, 3, 4, that means that it is placed in the PCIe slot that's directly linked to that NUMA node. So you're going to get the best performance from that NUMA node with that adapter. And if RSS was enabled and actually functional for this NIC, you would see an indirection table. And the indirection table basically tells you the processors that you will see traffic on. Now, if you're getting traffic on a processor that is not in your indirection table, there's something wrong. So that's a good way to troubleshoot whether or not your RSS is actually working. And I'll come back to this output after I talk about the next feature. So just to kind of wrap up here, we also have profiles, and the profiles are how your indirection table gets set. So you have closest static, NUMA static, and NUMA dynamic. What closest does is that it finitizes, it sets your indirection table to hit the closest NUMA node to your network adapter. So all those WAC zeros is where you're going to see your traffic. What NUMA static is going to do is NUMA static is actually going to spread traffic and process it among multiple NUMA nodes. So depending on how you want your setup to look like, you can choose from the different profiles. And I jumped at the gun for the demo, but before I move on, any questions about RSS? We'll start here. RSS is turned on when you have a vSwitch on the NICs. Yes, it is turned off. There's a couple misleading parameters, but I'll go over that here when we talk about VMQ a little bit. Okay, and yes.
You mentioned that proc 0 is where much other stuff is happening also, right? So is there a way to tell whether how much RSS activity is happening on proc 0 so that we can see if any of this stuff is going to help?
Proc 0 is where a lot of the system processing happens. Is there any way you can tell how many flows from RSS are actually on proc 0? Is that your question? There is no specific way to tell. The algorithm is kind of it's not dumb, but in that it's static, in that as a flow comes in, it's going to finitize itself to one entry in the direction table, and it's just going to go right to that queue in that processor. So you could have, we don't do a lot of load balancing for RSS. So you'll find that you can have one we call them elephant flows, just a flow that's hogging the processor. You can have one of those on one processor, and you could have 3 baby flows on another processor, or you could have a very bad skew and have everything mapped to processor 0. It's random, so it'll depend on the distribution from that startup. So if you have a bad distribution, one thing you can do is you can enable and disable the NIC. And what that's going to do is it's going to the TCP/IP stack is actually what controls the RSS keywords and secret hash. there's a secret key we plumb down to the NIC every time it comes down and up. So every time you enable and disable it, you're going to get a different hash and a different spread of traffic for the same traffic. Any other questions? CPU 0 would be bottleneck, that's correct. Your system would start to slow. Yeah, so you would see that. And you can see if other processors are bottlenecked as well. And that's how you know if you have a bad hash. So you can check the task manager, and there's other counters out there, perfmon counters that are actually much more accurate than your task manager. Your task manager is kind of a guesstimate, we'll say. All right, I'll go ahead and move on. So the next problem is, the popular trend now is to virtualize your VMs, virtualize your servers. So your company wants to virtualize, and you're moving all these VMs, or moving all these physical servers and physical guests to VMs. You see that as you're processing traffic, it's not being balanced fairly. It's not being distributed correctly. One VM could have multiple flows or could be hog in a box, and another VM could be starved for traffic. So what we found here is we implemented a technology called VMQ, virtual machine queues. And what virtual machine queues do is that it finitizes traffic destined for a VM, and that's based off of its destination MAC address. It takes all the traffic and it puts it on one queue. So you take the notion of RSS where individual flows are on a queue. Now all the traffic for a virtual machine is destined to one queue and then passed to the VM. So VMQ spreads traffic per VM NIC, and each VMQ can use at most one CPU in the host. And going back to your question earlier, sir, as soon as a vSwitch is bound to the NIC, that's when RSS gets disabled and VMQ gets enabled. So you'll see when you do getNet adapter RSS, getNet adapter RSS may still say true. But if there's a vSwitch bound to it, VMQ is then taken over. So that's something you kind of got to keep in the back of your head that hasn't been fixed. I know it's deceiving, but it's just in the way that RSS is still enabled per se. It's the filter that gets changed on the NIC. So now instead of having a filter for the 4 tuple, the filter is now the destination MAC address. And so let me go to the next slide. As the packet comes in, you see that blue rectangular box, the skinny box on the NIC. That's where the difference is. So you don't have the 4 tuple, it's the MAC address filter, which is then going to place the traffic into a specific queue based on the VM NIC's MAC address. As well as the VM NIC MAC address it gets created a queue for, we also have the notion of a default queue. And the default queue is basically our catch-all. So if your VM doesn't have a VM queue, everything's going to get placed into the default queue. And VMQ also helps in that it helps reduce latency in that we skip the routing and filtering. As a VMQ comes into a vSwitch, it has a VMQ ID. And from that ID, we know directly where to send it. So it helps decrease latency. But one thing is it's affinitized to one core. So up to now, one gig NICs have been pretty easy. We've been able to handle 1 gig worth of traffic on one core pretty easy. But with 10 gig NICs coming around, you find that one core is now bottlenecked right around 5 or 6 gigs, depending on the speed of the processor. So I'll talk a little bit more about that. I just want to finish up VMQ. VMQ takes traffic by the MAC address. It places it into a queue. It bypasses the routing and filtering and places it directly to the VM. And like RSS, you can also configure the processors that you use for VMQ. So you can move that traffic off of core 0, or say the first 4 cores, or place it on whatever NUMA node you like, and isolate it there so that that's the only place that traffic is being processed. So let me go ahead and give you guys a demo here. And as that switches over, the first thing I want to point out is let me get the right NIC here. Here you see we have slot 4, I have this Mellanox card placed in there. Enabled is still set to true. We have a base processor of 8, max processor 15, max processor is 8. But you don't see the RSS processor array and you don't see the interaction table. Now, on this box, I actually have, VMQ enabled. So I'm going to use that commandlet that I showed you before, getNet adapter VMQ. And this is going to tell you that slot 4 with Mellanox card enabled is set to true. That's why you weren't seeing the processor array in the previous RSS commandlet, because it actually has VMQ enabled. So that filter on the NIC is set for MAC addresses, not the Toplets hash. Furthermore, if you do getNet adapter VMQ queue, it'll tell you exactly what queues are on that NIC and what they're destined to. So slot 4 has a queue ID of 0. It doesn't have a MAC address, but you see that it has the host name. That is actually the default queue. Since it's the catch-all for the system, it doesn't have a MAC address. It's just left blank. Now, anything destined to the host also gets its own VMQ. So the host now has a MAC address of the VNIC. And then our VM1, has the MAC address of its VMNIC. And so I'm going to get out of this, and I'll show you guys a quick demo of what happens with VMQ. So I want to make sure that RSS is disabled. And what I have here is I have 2 machines connected back to back, just with 2 cards, similar cards. One machine is the physical machine, no Hyper-V, no nothing, and that's going to act as my sender. My second box is a receiver. I have Hyper-V on there, and I have this VM1. So we're going to be sending traffic from the physical host to VM1. So I'm using NTTCP. It is a just traffic generation tool we use internally. I'm going to have 16 flows pumping traffic, as much traffic as it can. And I'm going to jump into our other box. Oh, it timed out. And then I'll just get traffic going. And as the traffic starts flowing, you'll see that in our host, you have what's expected. You have your VMQ being processed on processor 8, because here we have our processor, group 0, processor 8. And inside the VM, you see similar. You see one processor. Okay? So that's what you're going to see with VMQ. Now, with VRSS, which is my next topic, let's go ahead and jump back to the slides. Let me finish this real quick. SetNet adapter VMQ, you have your base processor, number of processors, max processor number. And then the other one here that's different than RSS is getNet adapter VMQ queue. And that's the one I showed you guys, where it actually tells you the queue IDs and the queues that are allocated for the different machines on the system. And did the demo. Any questions about VMQ? Go ahead. It doesn't affect it. VMQ still works. There's just multiple modes that you have to be aware of depending on the traffic and the setup of your system. Don is the expert. Did you have a more specific question, or is it?
Yeah, we can address it when we get into the NIC teaming topic. Let's come back to how does VMQ and RSS work with NIC teaming. It actually works extremely well, but we'll come back to that there.
Behind you? I'm sorry, can you step to the mic? I could barely hear you. If
I think the question, if I heard it right, is if my VM migrates to another host, what happens to the VMQs that were assigned to it? You want to take that?
if it's migrated to another host and the network adapter is VMQ capable and has available VMQ queues, it'll get allocated its own VMQ. So it should work and migrate just fine, unless there are no VMQs available on that NIC.
So say in organization, enterprise, larger enterprise, it's like a lot of CR processes. Like, okay, so when I move one VM to another VM, it should say that, okay, I have to run maybe another commands there to configure the network card to set it up VMQ. That may be a change request process probably for the operations folks. So how it works, is everything automatic or is it something, again, I don't know, I think you should explain a little bit more.
Go ahead.
The VMQ should be enabled on all of your NICs that are set up under Hyper-V. VMQ should always be enabled under all of your NICs, on all of your NICs that are bound under Hyper-V at all times. If it's enabled and you're set up properly there, as you migrate VMs from host to host, VMQs will automatically be allocated for those VMs, subject to the resources available on the NICs that are on that host.
Okay.
It's all automatic. There's absolutely no change requests to be made anywhere in the network, assuming that when you originally deployed your Hyper-V hosts, you have VMQ-capable NICs in those hosts.
So one of the, like diagram actually was architecture that, okay, the port 1 is used by this VMQ1 or port 2 VMQ.
Yes.
So let's say if I have a physical host here, I have another physical host. My VM moved from here to another host. That on another host, that port 0 or port 1 is used by some other VM which was running on this particular host.
Oh, it'll actually create a new port.
Okay.
Yeah, it'll create a new port and the properties will be migrated with it.
You can think of VMQ as being ways to get into the virtual switch. The VM doesn't see the VMQ. The VM is seeing traffic coming from the virtual switch. And what the VMQ does is it enables us to get traffic more efficiently in and through the switch, back to Gabe's earlier diagram, in and through the switch as a single blob. It comes in with a tag that says what queue it is. We can map that queue to a VM. We can move that traffic very efficiently, lower latency, better traffic management.
Good. Let's see. Sorry about that. Any other questions before I move on? Okay. So I'll go ahead and move on. Now, you saw in the demo before that VMQ affinitizes itself to just one processor. So you're limited by the processing power of that one processor. So if you have a large web server that you had physical and you're using, say, 16 cores for it, when you try to virtualize it, you're kind of stuck or restricted by VMQ to only using one processor, regardless of the number of resources you have available. So in here we have an enterprise web server. You're trying to move it to a VM, and you see that regardless of the number of resources, you're stuck with one VMQ. So what we implemented, and this is a new feature in 2012 R2, we implemented VRSS, Virtual Receive Side Scaling. And what it essentially is it's RSS inside of the VM. And this lifts the restriction on your VMQ, placed on your VM by VMQ before, in that now, rather than using just one processor, you can use up to 16 processors in the host. So when should you enable VRSS? VRSS is actually disabled by default. We did that because the RSS logic that we did before is now done inside the vSwitch. So as I was talking about the network adapter still keeps the VMQ logic. It's actually oblivious that we're doing VRSS in the host. And what it does is it'll still signal your VMQ, but now we actually keep track of the flows and we do the spreading inside the vSwitch so that you can see, so that you get the spreading in the host, and then inside the VM, you just enable RSS like you would on a physical host, and you see the spreading across the multiple cores inside the VM. So The diagram gets a little more complicated in that the bottom is the same. You have your MAC filter and you have your VMQs. But what changes is once you get to the Hyper-V switch, you now have the toplets hash and the indirection table that you didn't have before with VMQ. And what that allows us to do is it allows us to keep track and schedule that traffic on a different processor, so you now can take advantage of the additional resources on the box. So to take advantage of VMQ, your network adapter does have to be VMQ capable, and VMQ has to be enabled, because we use that underlying capability to do the RSS spreading inside of the vSwitch. And then the second change you'll see is inside of the VM, you're now using multiple VPs rather than being stuck to just one. So just step by step, it's kind of complicated. As a packet comes in, it's going to go through your MAC filter. Your MAC filter will put it into a hardware queue, which then gets indicated to the processor. That processor is then going to check, it's going to calculate the toplets hash, it's going to check the indirection table and see if that traffic should be spread. And the way that's triggered is we take a look at the CPU utilization. This is all dynamic. So if your CPU utilization for that CPU is above 90%, we'll trigger the spreading and we'll start moving flows off one by one as needed. So if you move a flow off and you're still seeing 90%, we'll move an additional flow off. And we'll do that every second until we see an equilibrium or you exhaust your resources. So let me jump into a demo. The configuration for VRSS is somewhat complicated. Since we have both VMQ and RSS, you have to configure both, and you have to be aware of both. Because inside the VM, you're going to configure your box just like you would RSS normally on a physical box. Inside your host, you're going to configure VMQ just like you would like normal VMQs. So you have to be aware. The one caveat there is that traffic spread from your VMQ is going to be limited by your VMQ keywords. So if you only set 8 max processors, you won't spread more than 8 cores. If you set 16, you won't spread more than 16. So it'll limit how far VRSS can spread inside the host. So let me switch back and show you guys a demo. So what I'm going to do here is enabling VRSS is just as easy as enabling RSS on a physical host. So you're just going to set it to true. Now I'm going to start my traffic, my receiver, my sender. And here you'll see the more interesting story here is the host. You see as traffic ramps up, you'll start to see traffic on other processors start to ramp up. And that's because as we see it reach 90%, we start moving flows off to additional processors so that we can take advantage of the additional resources. And inside the VM, you see that you're also getting a clean spread across all the processors. Because RSS isn't dynamic like VRSS. RSS just sends your traffic based on this static indirection table. And here you see we're getting on a 10 gig card right around 9.6, 9.7 gigs. So you're no longer limited by the OS, you're now limited by the physical hardware. Any questions? No, it really doesn't apply to 1 gig. You need it, since one core can handle 1 gig pretty easily, you really don't need to do the spreading. When you're going to find it is when you start trying to do like 5, 6 gigs to a VM, or you have heavy application usage along with the network traffic. So SQL servers. We did a lot of work with SQL to make sure that we met all the requirements for a high I/O SQL server. So we've seen up to 40 gigs to a VM. So that was using a 40 gig card. It was a pretty powerful server machine, but we got up to 40 gigs with a 40 gig card. So you had a question? This is R2. It'll work with 2012 host with integration services. So you can have a 2012 host hosting R2 VMs. As long as you have the integration services installed, it'll also work. Any other questions? It was actually pretty cool. We had a problem with Oracle not too long ago, and we spent a couple days troubleshooting their issues. They thought it was in their installer, and they thought they didn't know what the issue was, and it turned out they were using 2012, and they were just bottlenecked by one CPU. So they installed 2012 VMs and the integration services, and it completely unblocked them. All right, so I'll go ahead and move on. Yep, go ahead.
For these heavy-hitting servers, are you seeing it more on the storage side or the LAN side, or can it be either or, typically?
More on the LAN side.
More on the LAN?
On the storage side, you're going to be bottlenecked more by your disk rather than the network. But
when you start talking about trying to balance storage traffic and networking traffic, typically in a converged scenario, your storage traffic is not going through the same processes as your Hyper-V data traffic. It can, if you're fully converged, so that your SMB or iSCSI endpoints are actually ports on the vSwitch, you can get there. RSS, VRSS does not apply to host ports on the vSwitch. It only applies to VM ports on the vSwitch. But if you do what's typically done in the Server 2012 R2 timeframe, typically there are dedicated NICs for storage that are separate from your integrated converged NICs that are doing your host management, maybe your cluster work, as well as your VM traffic. And on those NICs, you want RSS enabled because they're into the host directly. On the ones that are bound to Hyper-V, you're going to want VMQ enabled. And the result will be that you get traffic spreading on the host for your storage traffic, or you take advantage of RDMA, in which case you've got no CPU load anyway. And on your VM traffic, you've got VMQs, so you're getting spreading in, and then, of course, VRSS to give further spreading to the logical processors within the VM.
And I have a diagram that outlines that as we move forward.
Super, thank you.
How do you police this in a multi-tenant environment? I don't think I want. How do you police this in a multi-tenant environment?
So you have to use your VMQ keywords. That is, in fact, a problem we have today, is that there is no fairness. There's absolutely no fairness implemented. So we make it, that's why it's not on by default. It has to be an explicit decision by the host to enable it for that VM. And if a VM gets high traffic, it could definitely starve the system. So that's one warning. So and that's something, our scenarios here were web servers, SQL servers, which are being put on their own box, or large VMs. For a multi-tenant environment, it's not something you want to use. And how many VMs do you have that use more than 3-4 gigs at one time anyways? And that's enough for one processor to take advantage of. So that was really the pain point we were trying to hit, were large web servers. You have large NUMA node machine with multiple NUMA node machines that you can only use one VMQ on. So we didn't target the multi-tenant scenario. If that answers your question. Yes.
That would help in this scenario. Because if you want that specific VM because the customer paid enough to process more load, then you need to enable RSS, VRSS, etc. for them. But if they don't pay enough, then you can set up QoS.
QoS, yeah. The question was, how do you police VRSS on a system if you have like a multi-tenant or multiple VM environment? And the answer was you can't. So You can with QoS or by setting up the VMQ keywords, but if you have multiple VMs, if you have one large VM, it could starve the other VMs on those cores. So you can isolate the cores that it's going to be processed on, but you can't fairly distribute traffic to the multiple VMs. That makes sense? Yeah. Okay, so moving on. I'm going to spend some time on SRIOV. Quickly, how many people have actually deployed SRIOV or used it? We have one. So this is something that that was new in 2012, I believe. And what SRIOV does is, rather than taking the path through the vSwitch, through the VM bus, up to your VM, we are able to direct traffic directly from the NIC to the VM. So applications that are very, very latency sensitive, like financial workloads, where every millisecond count, this is something that they could use. Let me jump to the figure, because the figure is kind of interesting here, in that you see, from the network adapter, you completely bypass the vSwitch and the parent partition, and all the traffic is actually directed right to the virtual machine by this virtual function, or VF, that we use. So as traffic comes in, you don't get, let me rephrase that. One of the problems with this is that a lot of your policies are set by the vSwitch. So a lot of your port ACLs and filtering and monitoring is all done by your vSwitch. So SRIOV is only useful in a trusted environment. Otherwise, if you have multiple VMs and you don't trust them, you don't get that security that you would apply in the vSwitch. So I want to jump back here. It is disabled by default. Your BIOS has to be capable of handling SRIOV, and and your NIC also has to be capable. And it's useful when you're hosting many VMs in a trusted environment. So I don't want to spend too much time on SRIOV. So the NIC offloads takeaways I have here. The 4 technologies I covered were RSS, VMQ, VRSS, and SRIOV. RSS is on a physical host and provides high scalability of network traffic. VMQ fairly distributes traffic among multiple processors on a virtualized environment, anywhere where a vSwitch is bound. VRSS kind of provides the best of both worlds. It allows you to scale the multiple processors for one VM, and SRIOV allows you to bypass all the vSwitch processing for very high, very sensitive latency workloads. And just to kind of beat it again, VMQ is not enabled in a physical environment. RSS is, and as soon as you bind that vSwitch to the NIC, you're going to see that RSS is no longer going to be working, and VMQ takes its place. And the VM, now you have RSS and VMQ working. RSS inside of the VM, VMQ inside of the host. So to Don's point earlier, if you have an environment where you need to spread traffic for your host processing, so a lot of your SMB traffic or storage traffic all flows through the host VNIC, regardless of how many VMQs you have set up. And the problem there is we don't actually enable VRSS for the host VNIC. It's only for VMs at this point, and so you're stuck with one processor. And the way we get around that is, this is our preferred configuration, is if you need to virtualize your environment, we still recommend, if you're going to have live migrations or cluster, heartbeat, all that traffic is going to run through your VNIC. We recommend having your own NIC for that, so you can still get the benefit of RSS and spreading, and then have another NIC or another 2 NICs team together for your tenants in that environment, who can then take advantage of VRSS or VMQ, depending on the workload that they need. Any questions there? If you're using SRIOV, can you live migrate that VM? And the answer is yes, you can. It gets live migrated to another machine, and if SRIOV is enabled there, it will use the SRIOV path. If not, it will default back to the VMQ path. Go ahead. That's correct. Can you step up to the mic?
The thought behind that is that RSS benefits you more than having VRSS and VMQ for the live migration and CSV traffic?
No, it doesn't benefit you more. It's that that traffic runs through the VNIC for the host. And we don't have our VRSS for the VNIC. VRSS is only for your VM's traffic.
So if it was a converged networking configuration, those other things would also be VNICs, so then it'd be okay.
No, if it's a converged networking,
Your LM is also going to be a VNIC. Your CSV is also going to be a VNIC.
say that again, your LMs?
Your live migration network is going to be hanging off of a VNIC.
You've got two configurations possible. One of them is that you've got two NICs teamed into your Hyper-V switch, and everything in the host is a VNIC, and all the things, all your VMs have VM NICs. And we're going to use the terminology VNIC means a host partition virtual NIC off of the virtual switch, and a VM NIC is the synthetic NIC inside the VM. VRSS only works with synthetic NICs and VMs. It does not work with VNICs in the host.
So management OS NICs.
Management OS NICs that are attached to the Hyper-V switch do not get VRSS. The result is that if you have live migration, for example, through a VNIC, it does not get any of the benefits of processor spreading that your VMs are getting with VRSS or that you would get from a separate NIC with RSS.
So even if they have their own VNICs, they'll still be limited to one processor.
They will each get their own VMQ, which will help.
Yeah, because each VNIC will have its own VMQ allocated to it.
But you're going to look at, most likely for each of those VNICs, which will get its own VMQ, hence can get it to its own processor, you're probably looking around 3.5 to 5 gigabits per second as an absolute max traffic flow before you're absolutely burning that CPU up. If you really want more than that, the way to get it is to have a dedicated NIC for that live migration and or storage.
Okay, so in a converged fabric of 10 GB or something, you are going to hit that constraint.
You're going to hit that constraint. In a 1 gig environment, if you want to team 8 1 gig NICs together, I absolutely would put live migration and storage and everything else on the vSwitch because you're not going to need that spreading. You're going to be limited by your 1 gig NICs that you're coming in and out. Go ahead.
A big tricky question. What if for live migration network, I create instead of one VD, two, and then use SMB?
You can do that today, and you will get multi-channel, you will get the advantage of spreading, and you will get one processor per VNIC. Now, that assumes that you've got enough processors to spread across that those don't end up getting mapped onto the same processor. Because with VMQ, you still are going to be limited by the number of processors. So if you've got a 4-processor host, and you're asking for 5 VNICs and 10 VM NICs, guess what? That 15 entities are going to get mapped into just so many processors. They've only got 4 on the host, right? So you're going to overload that way. But if you've got a 32 proc host or a 64 proc host, sure, go for it.
So we can improve the experience. Well, to be honest, if we are talking about converged networking, at least 2 processors, each with 8 cores, should be used. And if we dedicate 2 cores, then we can achieve like 10 gigs.
I wish I could play that back over the mics because it's exactly the correct statement. The statement was, in a converged networking environment, I should be using at least two processors with 8 cores each. I've got 16 cores then available. I can map individual cores to each of those VNICs, which I can by setting the VMQ properties there. And I can spread around, and then I'm going to get really good performance with SMB multi-channel for my live migration, because I'm going to live migrate over SMB. I'll get very good results. All yours.
Any other questions? And it's your turn.
It's my turn. Are you going to stand up there and click it, or do I have a clicker?
There you go.
I don't do well on top of the stage. I much prefer to be out in the audience. I've too many years as a college prof, and if I ever went up on the stage or stood up at the blackboard, all my students went to sleep. So I much prefer to be down here. So I'm hoping I don't get too much feedback off the things. How many of you have used Windows Network NIC teaming? Pretty good. Yeah, that's what we usually see. How many of you are ready to go back to your third-party vendor NIC teaming? One? We know there's a couple of small features that some people are very, very insistent on that we haven't quite got yet. See me afterwards and let me know what the one is that's keeping you off of it, because we know there are very few. How many of you have had a good experience with Windows Network NIC teaming? How many of you are using dynamic NIC teaming? The dynamic mode in Server 2012 R2 came along. Working for you? Spreading things around, working things well? Good, then my talk's done. Okay, NIC teaming has some elements to it. Boy, I don't like hearing myself in the speaker. I'm going to have to step back a little bit. Okay, so the all-static distribution that we had in Server 2012, where everything was assigned when it came in, all the flows got assigned to individual NICs, and we mapped them there, and we left them there. And that caused sometimes, Gabe made the reference to elephant flows and baby flows. And you could get multiple elephant flows affinitized to the same NIC, and you got some load balancing that wasn't very good. All the hashes were static, everything stuck there, and we didn't make any attempt to balance them. So in Server 2012 R2, we added the dynamic mode, where we continuously monitor the traffic, and we will move it around. And what we do with this is we actually watch the traffic flowing. For every flow, every 5-tuple flow, we're monitoring that flow. Just as in human speech and in conversations, even when I'm talking here in a monologue version as opposed to a dialogue, I take time to breathe. I take moments of gap, end of sentences. Those little tiny gaps are enough that we can check when we detect one of these short gaps and say, oh, it's a long enough gap that packet reordering is unlikely to occur. Let's check to see if we should move this flow. We call that dividing the flow up into flowlets. And we make sure the gap is long enough that we're not going to cause you processing problems by causing TCP packet reordering, for example. But we also don't have to have them that long to be able to do this very effectively. So we do flowlet redistribution, continuously moving flows to the most least recently used NIC. Is that confusing enough? We always basically are looking at the current utilization of all the NICs in the team, and whenever a new flowlet begins, that is, whenever we detect that there was a gap long enough in a flow, it becomes eligible for redistribution, and we will redistribute it to the NIC that we've detected that over the last short time period has been least used. So we're continuously moving this around. So this is a picture of how it worked in 2012. If you follow any particular color, you'll see it always goes to the same NIC. In 2012, you can follow a color, and you'll see it gets redistributed across the different ones. We have some additional resources available online that you can look at. Gabe's got a really good blog series. I think you're just about to publish your last one. Turn it on, come on up.
So there was a gap in our deep dive series as far as troubleshooting.
You're not on yet. Somehow, there you are.
Let me get away from you, Don.
Okay. I did take a shower this morning.
So in our VMQ deep dive, what we found was a lot of people are still having trouble trying to diagnose problems as to what is a VMQ problem, what's a NIC problem, what's an issue with the driver. So I have a diagnostics blog I've been writing, and I've emailed it to MVPs, people within the company, just making sure that I hit all the points. That'll be coming out soon. So if you guys are having trouble with VMQ or any kind of issues there with performance, I'm hoping that this blog will be able to help you. I was going to publish today, but I decided to wait. I should have that out early next week, and it'll be in addition to what's out there already. And the VMQ deep dive, I talk a little about what we talked today, a lot about what we talked today, and I go into a little more depth. And then I also did a networking interview that quickly goes over the concepts, pretty much everything I talked about today minus SRIOV. It's just the progression from RSS to VMQ to VRSS, and the demos are there as well. So if you guys have any questions or need something to refer back to, that's always there. You can always shoot me an email as well. I'm more than happy to take questions and problems that you have. And with
Yeah, there's also, it's not mentioned up here, but if you bing for NIC Teaming Deployment Guide, you will find separate ones for both Server 2012 and Server 2012 R2. Look at those. If you have any issues with either of those, get back to me. I am the one responsible for both of those, the one who actually put all those words on paper. I think one's 40 pages for Server 2012, and it's over 50 pages for Server 2012 R2. So if you don't find your answer in there, or it's buried so deep you couldn't find it, send me an email, don.stanwyck@microsoft.com. Question? Prior slide.
Do all the switches have to go to the same switch?
the same.
No. Our actual, okay. I should back up. We didn't have the tutorial on NIC teaming part in here, but I should back up and just talk a little bit about that because I think some people will find it useful. NIC teaming comes in two generic modes. Switch-dependent modes, where you do have to connect to the same switch or at least the same multi-chassis switch, and switch-independent modes. For switch-dependent modes, a switch configuration is required. And the most common switch-dependent mode is LACP or 802.1ax. It goes by different names. That's a very good mode, but the key characteristic of that mode is that we have no control over where traffic arrives. The switch is making all the decisions. Some switches can't make very good decisions. Some of them do quite well. If they can do 5-tuple differentiation and spread the load in, you can get some very good bandwidth in over an LACP team. If the only thing they're doing is mapping destination MAC address to a team member, and we know that there are some data center grade switches, so-called, that's the best they can do, don't use that. You won't like the results because you're going to get very low bandwidth in for any given VM. So you're really looking for something which can do some effective spreading if you're going to use switch-dependent mode. The way around that is to use switch-independent mode, where we control the incoming traffic. And we can work to make sure that your VM is getting the traffic it needs. So switch-independent mode versus switch-dependent mode, such as LACP. And then the second parameter, so think of two parameters. First is, what's my connection architecture, switch-dependent or switch-independent? The second one is, how do I want to distribute the load? Outbound, which also affects inbound. And in switch-independent, it affects inbound. In switch-dependent, again, we can't touch the inbound. In switch-independent mode, I can do it with static address hash mode, I can do it with static Hyper-V mode, or I can do it with dynamic mode. And dynamic mode is the mode that we recommend for all application. The other question that frequently comes up is, what about active standby? That's like building a nice 4-lane highway and keeping one lane each direction blocked just in case there's ever an accident in the other one. You wouldn't like it if the traffic engineers did that on your commute path. Why would you do it to your users? You've already expended all the resources. You've already got all the cables connected. You're already using up all the switch ports. You've already got everything else set up. Why on earth would you keep something in standby? You know why you do it? Because years ago, it was the only mode you could make work on that proprietary NIC teaming solution you used to use, and so it got written into the manuals.
There is another from the field. My customer is using 1 GB as a standby adapter and 10 GB for the normal adapter.
Okay, officially we don't support teaming of different speed adapters, but I actually call that out in the guide as the one use that I can actually see somebody doing, and that is if you have a 10 gig adapter and you want to make sure you have communication, if that 10 gig adapter fails, team it with a 1 gig adapter. Yes, you're going to get a serious service degradation, but you'll still be talking. But if you don't have two 10 gig adapters that you can use to team, you can team a 10 with a 1, put it in active standby, and that's better than having no team at all, but only just barely.
Yeah, until you fail over.
Yeah, until you fail over. And when you fail over, you will still have communication even though it's not very good.
In the presentation, it seems like you're implying that you go to NIC teaming, RSS, VMQs, all that stuff, you just kind of ignore it.
No, it all works perfectly.
Yeah.
On the top of a NIC team is a virtual adapter. We call it the TNIC or the team interface. That team interface exposes all the RSS queues and all the VM queues of the underlying NICs. In switch-dependent modes of NIC teaming, because we can't tell where the traffic's going to arrive, we have to program the same queues on every NIC. Which means if you team something that's got 16 queues with something that's got 64 queues, we're only going to tell you you've got 16 queues. But in switch-independent mode, where we can tell you where the traffic is going to come in, and we control it, we instead go to what we call sum queues mode. And we will tell you, if you take two 64 queue NICs, we'll give you 128 queues at the top of the team. So you've got lots of queues to play with. And RSS and VMQ are really just two different uses of the same NIC construct, which is a queue. Gabe referred to the filters changing. For RSS, we use a filter related to the Toeplitz hash. For VMQ, we use a filter related to the MAC address and VLAN. It's just a filter on a queue. It tells the NIC, filter the incoming traffic according to these filter rules and throw it in one of these queues. So with NIC teaming, we can give you a lot more queues. We'll give you the sum of all the queues if you're in a switch-independent mode of NIC teaming. Other questions?
Go ahead.
So what happens with VNIC on the host side and RSS? How is that?
VNICs on the host side get locked to a single CPU. There is no RSS for VNICs on the host side. No VRSS, no RSS. They will, where they connect to the vSwitch, they will get a VMQ, assuming you have enough queues and so on. But they become VMQ eligible. They will get VMQs as resources are available. And that's distributed across processors. It's a Toeplitz hash. It's a 5-tuple hash. We actually do. Not for load. For NIC teaming, we can distribute the team by IP only. And actually the way we do it in NIC teaming, if you select either dynamic or address hash as your mode, we distribute the load based on the best calculation we can do. We'll do a topeless hash if we have all 5 tuple available, but maybe your VM's using IPsec or for something else where we can't get to that information. Then we'll hash on the IP addresses. And maybe you're not even sending IP traffic. Maybe you're sending some other L2 traffic.
UDP.
Well, UDP is still going to be over the IP, and I can get my 5 tuple off the UDP.
For LBFO?
Yes.
For RSS.
For RSS, well, we added that in Server 2012 R2. We have RSS for UDP now.
I didn't know that.
Yeah. But for NIC teaming, we'll take the 5 tuple hash if 5 tuple is available and visible to us. If it's not, we'll fall back to an IP address source and destination hash. And if it's not IP traffic, we'll actually fall back to hashing the 2 MAC addresses, source and destination MAC addresses. So we automatically fall back to using the hash of what's available to us.
So if I have a 210 gig income, is when you teaming that, can someone report and say it's showing 4 gig or is it showing exactly 10 gig, 10 gig?
If you look in GetNet Adapter, for example, and you've teamed 2 10 gig NICs, the TNIC will show up as a 20 gig adapter.
But in terms of traffic, are they really pushing 20 gig?
Yes, in and out. Depending on the distribution, you will get 20 gig in and out. I can demonstrate it and show you.
The question is, what about the other side?
The other side, of course, is subject to what it has. Okay? If you've if you're talking about live migration traffic and you have set it up over SMB multi-channel, if you set it up over SMB multi-channel and the other side is your file is the same way, there is nothing that would prevent you from getting potentially, and this is actually one of the downsides, if you don't use VM QoS and keep those ports tuned down a little bit, live migration is a greedy sucker. It will take all 20 gig. Subject to, of course, the fact that it doesn't have VRSS, so those processors can't get that hot. They're going to get up to around 5 gig each and stop. I have 2 10 gigs. I can take each TCP stream that's coming from a source and put it on a different NIC. Now, and with multi-channel, it will take the streams from live migration and break it up and send it as multiple parallel TCP streams. And so I can run those different TCP streams to different NICs. Because we spoof the MAC address. We certainly do. Every TNIC, every VNIC has its own MAC address, right? One stream will have 1 MAC address per NIC. We use ARP management within the team to make sure that the switches never see a MAC address on more than 1 NIC. Okay? And then we will rewrite the source MAC as necessary for data flow, which the switch is not supposed to look at. We know there's a couple of storage vendors, and I hope none of you are one of them, who violate the rules and try to send traffic back to the source MAC that you received the packet from. That's a violation of the RFC. It will get you in trouble. You are required to ARP for that IP address and send to that MAC. And we will leave those storage vendors nameless, but some SANs out there actually do it wrong. And we've had to have some talks with them because they break customer environments. Question back there.
Issues with or recommendations against using the dynamic algorithm with LACP mode?
Dynamic works very well in LACP mode, but keep in mind it's only balancing the outgoing traffic, the egress traffic, because the ingress traffic is controlled completely by the switch. Does that answer your question? For teaming, if you will just go Bing or Google if you prefer, NIC Teaming Deployment Guide. You will find there's 2 at Microsoft.com that are there.
Chimney? No, we actually recommend that you disable chimney. That-
TCP Chimney, yeah, go ahead.
You go ahead.
TCP Chimney has been found to help a very few number of workloads and seriously do damage to most of them. It's only available on one vendor's NICs, and the TCP stack that's in the NIC is not as good as what's in the Windows OS. It's off by default. But there are 1 or 2 workloads that do perform better with Chimney. So we haven't said you can't use it, but we recommend that you test your workload with it and compare it to without it, and we think you will find that it works better without it. Yeah, we're not big fans of TCP Chimney.
So VRSS is disabled by default because we do the extra calculation and because of the fairness issue that they brought up. So you'll want to enable it only for the workloads you know it'll benefit, but VMQ and RSS are both enabled by default. That's correct. Yeah. Yeah, and it should be enabled by default, like I said. So once the vSwitch comes up, the only thing you guys would have to do is actually configure it to use the processors you want it to. And what we're finding is a lot of people don't even configure it. They just let the base settings or default settings take control, and it seems to be doing just fine, especially RSS. VMQ, we've had some issues with driver quality. So there's been bugs in drivers, and we've seen that pop up here and there. And that's one of the main reasons I'm also writing this new blog, is because we need to isolate the bugs that are driver issues versus OS issues. And on 1 gig NICs on VMQ, it may show up enabled, but it's actually disabled by default. That's in my 3rd blog post. So you'll see that even though VMQ shows up as enabled, it's not working under the covers. And it's only because on 1 gig NICs, we really didn't see a reason to have VMQ enabled.
But you have to turn it off on 1 gig NIC. On some of our workloads, it's caused latency.
I keep hearing, I keep hearing that. I keep hearing that, and so I'll look into that. But
yeah, we want to work with you to get to the bottom of that, because from our understanding, it can't have any impact. But obviously it does.
If it's doing something
it's not
on the
that we
NIC,
don't
that's
believe you,
definitely
it's
something
that
I
we've
wanna-
never seen this or heard about it before. So we want to work with you to get to the bottom of that.
Yeah.
The statement is that he's got a workload. Okay, first of all, in the OS, VMQ is automatically turned off on 1 gig NICs. Under the OS. It's in the OS. It's turned off. It's all the way across the board. 1 gig NICs, VMQ is disabled. And that's because we don't see performance benefit to VMQ on a 1 gig NIC. The CPUs can keep up with 1 gig without any problem. They won't enable it in the OS that we're aware of. There are just the keywords that, as far as we know, they're not turning on. Now, having said that, we are hearing for the first time at this conference that some people are discovering that even though it's off in the OS, that they have to explicitly turn it off again to get better performance, that they're actually seeing a performance degradation from their NIC. So this is news to us, and we're very eager to look into it. Gabe will be responsible for helping that, making sure that takes place. That we dig into that 1 gig VMQ issue.
Whatever I find, I'll post on the blog, and I'll add it to the bottom as like a note, or I'll actually point
we found that there were a lot of issues and people were recommending that you just turn RSS off, which really isn't the right thing to do because then you're just limited to one processor. The same thing's been happening with VMQ. A lot of these issues haven't been fleshed out because the recommendation is just turn it off and then everything will get better. But when you turn it off, you're limited to just one queue or one processor for all your VMs. So it's not the right thing to do. VMQ actually is a good way to, is the right way to spread your traffic to the VMs. And I want to make sure that we get the word out there because it's just been running rampant that turn VMQ off.
There's one other thing that Gabe alluded to a moment ago, and that is there's a known hardware driver bug that's affecting people in a particular configuration with 10 gig NICs in particular blade servers. If you think that's affecting you, talk to us and we'll give you advice. We also are happy to announce that we're in our hopes and expectations within a matter of a few weeks that will no longer be an issue. We believe that they have finally fixed it, and now we just have to get it out through the publication chain. And once that update occurs, it's a firmware and driver update that will occur with those NICs. And once that occurs, then we won't have that issue anymore.
Is that on Windows 2008?
It happens any blade server with that particular NIC running any version of Windows OS with VMQ.
You're fine. Go ahead.
As far as tuning across a cluster, I would assume you would set the same parameters that are required.
No requirement.
Yeah, I don't know of any requirements, but you would want to have the same settings. So that,
yeah.
I don't see why you would want to change the settings.
No impact at all on the cluster. There's no direct impact on cluster management or on cluster traffic from having it configured a particular way. The one thing that I think Gabe would advise you is, when possible, always making sure that your base OS is not 0, and base processor is not 0. And keep in mind that the odd number processors are really just hyperthreads, and you want the hyperthreading off anyway. So think of only even-numbered processors as being real processors. Don't map any of your traffic to 0, and then just figure out where your other ones are. When possible, take your 2 NICs and consider, if you're in switch independent teaming mode, for example, make sure that they're in different processor sets. So you might make one 2 through 6 and the other one 8 through 12. Something like that.
Inside the virtual machine with the VRSS, do you also want to move the, or do you want to also move the VMQ off or the RSS off of the base department 0?
Especially in that case, because in that case you're going to be expecting a large amount of network traffic. Yeah. And what happens is
Mic on?
Sorry. And so what's going to happen is the VMQ is actually going to be hitting processor 0 more and more with interrupts, and it'll start to fill faster, and it'll be the first processor to hit 100% utilization. So flows will get mapped off, but they get mapped off slowly. So you'll see your machine really start to become unresponsive. So my recommendation is absolutely move it off of processor 0 as soon as possible.
Even in a VRSS configuration?
Even in a VRSS, yes. Any other questions?
If not, please make sure you evaluate the session. I ended my session yesterday by pointing out that unlike your car dealership where they get paid based on the reviews, we get paid either way. But there's bragging rights in Microsoft for getting good reviews, so we always look forward to them. Thank you.